let's factor this quadratic. So taking a look at this guy, we have a binomial, a quadratic binomial. We have different techniques that we can use to factor this, but no matter what, we always have to start off with our most basic factoring technique, which is common factoring. If we can common factor, we should do it right at the beginning because it's going to make our life a whole lot easier. So is there a common factor here? Yes, it's 6. So let's take out a 6 first. So we are going to take out a 6, and we're going to be left with 9x squared minus 1. All right, so there is a very easy way to factor this, and there is a much longer way to factor this. And until you can recognize the easy way, you got to go with the long way, which is decomposition. So there are 2 ways to factor this. We're going to take a look at decomposition. Much slower, but you need to know it so that you start to recognize when there's a shortcut. Okay, so if we were to write this as decomposition, I'm just going to rewrite our equation here. 9x squared minus 1. We know that we can use decomposition when we have a trinomial. We don't have a trinomial, it's a binomial that's missing the middle term of the trinomial. So let's force it into, let's make it into a trinomial. So it's missing the x term, so I'm just going to throw in a plus 0x. So I just added that guy in, and I'm allowed to do that because 0 times x is 0. So these 2 expressions are equivalent. So now I can use decomposition because I'm going to look for 2 numbers that multiply to -9 and add to 0. If you don't know the rules of decomposition, go back and watch a previous video. So those 2 numbers have to be opposites of each other if they're going to add to 0. So they have to multiply to -9. So these numbers have to be 3 and -3 because then that's going to add to 0. It has to be the same number just with a different sign in front of it if it's going to add to 0. So we have, then we would break up our middle term, 0x into plus 3x minus 3x minus 1. And then we're going to group in common factor. So I'm going to group these 2 together and these 2 together. And then I will be left with a 6. And if I common factor the first guy, the first 2 terms, I can take out a 3 and an x. So I'm going to do that. I'm going to take out a 3 and an x, and I'm going to be left with 3x minus 1. And then the next 2, they don't have anything in common. So I could take out a 1 or a -1. But because this leading coefficient is negative, I want the x to be positive. So I'm going to take out a -1 and be left with 3x plus 1. And taking a look, I realized I made a mistake. These 2 don't match, and they don't match because I didn't divide properly. When I took out a 3x out of here, it should be left with +1, not -1. So I'm going to go ahead and change that. And now I can see that my 2 binomials match. I know I've done this right. So I'm going to common factor this whole thing again. So I'm going to be left with a 6. I'm going to take out what they have in common, which is 3x plus 1. And then I'm going to be left with 3x here and minus 1 here. 3x minus 1. Okay, so we're done. So we can factor this by decomposition, but there's a way to get this done in 2 lines, not 1, 2, 3, 4, 5 lines. So we can see this pattern here. 2 weird things happen. 1, when we found our 2 numbers to break up our 0 term, it was the same number just with an opposite sign. And the other weird thing is, look what it gave us as our 2 binomials. The same binomial, but again, just a different sign in the middle. These are called conjugates, and this is always going to happen when we have 2 numbers that come out here that are opposite of each other. And that's only going to happen when we have a 0 term in the middle. And that's only going to happen if it looks like this. If it looks like something squared minus something else squared. So just think back to here. If this number was a 6, we couldn't do this because no 2 whole numbers or integer numbers multiply to 6 and add to 0 because 6 is not a squared number, but 9 is a squared number. So the technique that's much faster to use to solve this is called difference of squares. We can use difference of squares when we have a binomial, subtraction in the middle, so difference, and 2 squared terms. This 54x squared is not a squared term. The square root of 54 is not an integer number. Either is 6, but once we factored out the 6, now we're left with 2 perfect squares here. So how to factor a difference of squares, I mentioned that we are going to get the exact same answer, but we're going to do it in much fewer lines, is one common factor if we can. Check if we have a difference of 2 squared terms, we do. And then all we have to do is take the square root of this guy and the square root of this guy. So I'm just going to do it on top. If you take the square root of 9x squared, we would get 3x. And if we take the square root of 1, we would get 1. So if this is confusing you, just ask yourself what times itself would make 9x squared, and it would be 3x. So what we would do now is we would rewrite the 6, and then we're going to break this up into 2 binomials. And our binomials are going to be made up of these terms. We're going to add these terms and subtract these terms. So we're going to make 2 opposite terms. They're called conjugates. 3x plus 1 and 3x minus 1. And we're done. And if you take a look, we got the same answer here, but we did it in 2 lines. 1, 2, we're done. Look at all the work we had to do here. Look how fast this one was. So difference of squares is kind of like a trick, but if we can recognize it, then it's so much faster if we do it. So again, we need a binomial. We need a difference between 2 squared terms. If this wasn't a squared number, we couldn't do this. Same with the 1, okay? So then all we have to do is take the square root of both the terms. Here we go, and rewrite both the terms in conjugate form. So we're going to add the terms together and subtract the terms together. The key is that the order matters. So the square root of this guy has to go first, and the square root of this guy has to go second, and we are done.